Good morning to my co-learners. Let us go to our video lecture today. We are going to discuss about GATE lecture. I am Deepana from Department of Civil Engineering, working as Assistant Professor in SA Engineering College. Let us start with a quote that success is a sum of repeated efforts day in and day out. Whatever we are doing, we should do it regularly so that it definitely lead to some success. These are the topics will be covered today, which is syllabus, introduction, bending moment and shear force in a statically determinate beam, simple stress and strain, and some of the GATE questions related to it, and conclusion. This is the GATE point of view, in which totally we are going to write about for 100 marks. Out of 100 marks, particularly civil engineering subject will hold up to 72 marks, and for 72 marks we are going to write. In this 72 marks, there is a subject-wise splitter. For engineering mechanics and solid mechanics, the allocated marks is up to 8, and structural analysis 3, construction materials and management will 3, complex structure 6.5, and steel structures will go around up to 4 to 4.25 marks, and geotechnical engineering is to 15 marks. Fluid mechanics and hydraulic engineering will score up to 7 marks. Water resource engineering is 7.7 marks. And environmental engineering is 9 marks, and transportation engineering is 12 marks, and finally geomatics engineering will carry up to 12 marks. And this totally we are going to discuss about this 8 marks, and we are mainly concentrating in this 8 marks. This is a split up for solid mechanics, and this is a syllabus. In solid mechanics, we have bending moment and shear force for statically determinate beams. We are not going to discuss about indeterminate beams and all. We are going to deeply discuss about statically determinate beams alone. Then we are going to discuss about its simple stress and strain relationship, simple bending moment theory, flexion and shear stress analysis, shear center, uniform torsion, transformation of stress, buckling of columns, combined and direct stresses. This is the overview of solid mechanics. Actually, solid mechanics is a branch of engineering which deals entirely about the behavior of a solid. We have to know about a solid so that it can be used efficiently where they can be used. And structure is typically compared to a human body. Like is compared to as columns, and footings is compared to as our footing, and other beams, columns and other slab is related to our skeleton body. These are the types of a support. In roller support, it used to roll in a particular plane. It tends to move. It tends to move in a particular direction, so that it tends to move forward and backward. In a pinned support, it is fixed to a plane. According to the types of a support, we have types of reactions. In roller support, we have one type of only one reaction, and in pinned support we have 2 reactions, and for fixed support we have 3 reactions. One is towards horizontal direction, and towards vertical direction, and other towards moment. Types of a beam. According to the types of a beam, we have simply supported beam, which simply rests over the support. Cantilever beam, in which beam is fixed at one end and free at other end. Next, overhanging beam. Overhanging beam can be singly overhang or double overhang. According to the extension of the support, we used to say it as single overhang. If it extends in one side, it is called as single overhang. If it extends on the both of its sides, it is called double overhang. Next comes the continuous beam. If a beam is continuous more than 2 supports, it is called as continuous beam. And fixed beam, if both of its ends are fixed, these are the types of a load. We have concentrated load, uniformly distributed load and uniformly varying load. If it is a concentrated load, it particularly placed on a particular portion, it doesn't travel from one place to another, it sticks to one point. When it comes to uniformly distributed load, the load is uniformly distributed over the entire span, maybe to the entire span or else to the part of a span, but it is uniformly distributed. When coming to the uniformly varying load, we will be having a variation in the load, which is maximum at one end and the minimum at other end. And coming to the bending, Bending of a beam is like if you have a scale in our hand and if you are applying a load in the center of it, it tends to deflect in giving this support, it is called as bending. And these are the examples of a simply supported beam, and this is a simply supported beam which is simply rest over the support. And this is a fixed beam where both the sides of it are fixed, and this is overhanging beam where you can able to slide, and this is a double overhang. Continuous support where we doesn't restrict our support within two spans, it goes more than its two spans, so it is called as continuous beam. And sunshade is an example of cantilever beam. And these are the supports, and we have to remember this part, which will be more useful in our gate lecture, which is a fixed beam will have three types of supports and three types of reactions. And for hinged support we will be having two types of reactions, and for roller we will be having one reaction. And these are the loads. Coming to the external force, according to the mode of application, it is called as compressive force or tensile force. If I am applying pushing force, it is called as compressive force. I am applying a load like a pushing manner, then it is called as a pulling manner, then it is called as a tension force. And this is this. When we apply a load, the material tends to react, and due to the reaction or due to the resisting force, due to the overall force caused area, this is called as stress. And we can split the stresses into direct stresses, indirect stress, and combined stress. Direct stress can also be called as simple stress, where simple stress is splitted as shear stress and normal stress. And normal stress further is divided into tensile stress and compressive stress. Whereas if I am giving a pushing load, it is called as compressive stress, and if I am pulling an object, it is called as tensile stress. And indirect stresses, due to the application of direct stresses, there will be some indirect amount of stresses which may be torsional or bending. If both the stresses like simple stresses and direct stresses combined together will act as a body, it is called as combined stress. And these are the practical explanation. These explanations are also asked in gate. You should remember this. If it is a direct stress, it is a definite load by area. If it is tensile stress, tensile load divided by area. And it is compressive stress, it is due to this, in this part you have to remember this, two equal and opposite pushes. And in shear stress you have to remember this, two equal and opposite forces which act in tangentially. You should remember this word tangentially. And these are the strains. Due to the load or stress, there will be some changes in the dimension of a body. That change in dimension is called as strain. Strain is according to the stresses applied. If the strain is due to tensile stress, that strain is called as tensile strain. Due to the tensile strain, the length of the body will elongated. And in compressive strain, we will be having compressive force. Due to compressive force, and volumetric strain is due to the change in the entire volume. And these are the examples, like I am compressing a force, it is called as compression force, and I am pulling an object, it is called as tensile strain, and I am twisting it, it is called as shear stress in a tangential manner. If I am twisting it according to the ends of a body, it is called a torsion, and the beam is like bending as which we discussed earlier. If I am applying a load, it tends to deflect in a position. And these are the points to remember. Whereas stress in mathematically it is expressed as load divided by area, which is P by A, and strain as change in length divided by original length, which is delta L by L. Coming to determinate structure, and from the starting of the lecture itself, I told which is we deeply discuss about the determinate structures alone. We are not going to discuss about indeterminate structure. Determinate structure is the one which we can able to solve the entire structure only with equilibrium equations alone. That structure is called as determinate structure. Equilibrium equations are summation of V is equal to 0, summation of H is equal to 0, and summation of moment, whereas summation of H is forces due to horizontal forces, and summation of V represent vertical forces, and summation of M represents total moment in a structure. If a structure can't able to solve only with the equilibrium equations, and if we need additional some amount of equations, that structure is called as redundant structure or indeterminate structure. And coming to shear force and bending moment, According to the types of a force, according to the force applied, the variation in the forces in the beam is called as shear force moment, and the variation of the moment in a beam is called as bending moment. This is positive shear force and negative shear force. If I am applying a positive bending moment, it is like laughing symbol, which is the curvature will be like this, and it have a concavity on the upwards. It is also called as sagging bending moment. And negative bending moments, it's like crying, or it is called as hogging bending moment, whereas the convexity will be on the upwards of the beam. And this is an example where we solve a beam. This is a cantilever beam. As I said, in a cantilever beam, it is one end is fixed and other end is free. And in the cantilever beam, we are having a point load. For a cantilever beam having a point load at the end, for a cantilever beam carrying a point load at its end, its shear force diagram will be a box, which is we doesn't have any other loads other than this point load. Due to this point load, it tends to its shear force diagram will be rectangle, and its bending moment diagram will be linear, which is called as a triangular bending moment. And this is an example for cantilever beam. And if we having a cantilever beam having a uniformly distributed load, its shear force diagram will be linear, and its bending moment diagram will be parabolic. And if we having a cantilever beam having a uniformly distributed load, its shear force diagram will be parabolic, and its bending moment diagram will be cubic parabolic. And this is a gate question which related to our discussed previously. For a cantilever beam, bending moment will be 0 at. We have discussed about 3 conditions. In a cantilever beam, if they just asked only about the cantilever beam. In a cantilever beam, where the bending moment is 0. If I am applying as a point load, the bending shear force diagram will be rectangular, and bending moment diagram will be linear. If I am applying a cantilever beam UDL, its shear force diagram will be linear, and its bending moment diagram will be parabolic. If I am applying a uniformly varying load to the cantilever beam, its shear force diagram will be parabolic, and its bending moment diagram will be cubic parabolic. Whatever the loading conditions may be, there will be a 0 bending moment at its ends. So that we can conclude that if a cantilever beam having any other types of load, there will be 0 bending moment at its end of a beam, at its free end. This end is called as fixed end, and this end is called as free end. So at free end of a cantilever beam, we will be having 0 bending moment. And let us conclude the session by saying, திருக்குறள் தொற்றனை தூரும் மணற்கேணி மாந்தர்க்கு கற்றனை தூரும் அறிவு. எந்த அளவுக்கு நம்ம படிக்கிறோமோ, எந்த அளவுக்கு நம்ம படிச்சுட்டே இருக்கோமோ, ரிப்பீட்டடாக கன்சிஸ்டண்ட்டாக, அந்த அளவுக்கு தான் நம்மளோட அறிவு இன்னும் அறிவு பசி தூண்டிக்கிட்டே இருக்கும். அந்த அளவு இன்னும் நம்ம படிச்சுட்டே இருப்போம். ஒரு சப்ஜெக்டில் டெப்த் நாலேஜ் நம்மளுக்கு கிடைச்சிட்டே போகும். ஹாப்பி லேர்னிங். தேங்க்யூ.